Okay, for each problem, use the method of cylindrical shells to find the volume of the solid that results when the region enclosed by the curves is revolved around the y-axis. So this one's interesting because when it says it's revolving around the y-axis, you still want the upper and lower bounds to be x's, and it'll be dx. So when it's a cylindrical shell, even though that says y-axis, we're still going to be dealing with the x's, and I'll show you what I mean. This tells us what one of the functions is. Y is equal to 2 times the square root of x. The other function is just y is equal to 0 between 1 and 4. So let's look at what that looks like. So this upper function is y is equal to 2 square root x. This lower function is y is equal to 0. And where we're looking at is just the region where the x's are equal to, between the region where x is equal to 1 and x is equal to 4. And it says we're going to revolve around the y-axis. That's what that means, by the way, when you see that. So when we do that, it looks like this. And remember what we said over here, we are going to be using cylindrical shells. So this is what that means. We're going to be doing some drawing. So, and think about Russian stacking dolls, right? Inside one is another, and then another, and then another, and it seems to, when you're little, it seems to be unending. It's kind of what's happening here. So let's say we draw a cylinder. From here to here, so that represents the radius. This represents the height, right? Well, there could be another one here. We could do the same thing, and then another one, and we could be doing this infinitely close. So we would have these infinite stacking cylinders, and that's one way to find the volume of these weird shapes is this cylindrical shell method, and this is the setup to the function. So volume equals 2 pi instead of just pi, it's 2 pi from lower to upper bound, and then it's the radius times the height times the width of the cylindrical shell. So if you're rotating about the x-axis, the cylindrical shell will be drawn like that, and y's will be the height, and it will be dy. But if we're revolving around the y-axis, we're still dealing with x's. Now, what's important to note is radius is, so let's come over here. Look at the radius. We just went from here to here. Well, at any given point, here, it's just between, it's just an x value. That distance right there is an x value. All right? Or if we were drawing it like this, that's a y value. And then the height, this height right here, is this upper function subtract the lower function. So when you have it in like this height is upper subtract lower, or right subtract left, and this is either going to be x or y, or if it's been shifted, it'll be x plus y or x minus y, depending on which way it's shifted. This one, we're just right about the y-axis, so we don't have to worry about a shift. So let's go ahead and get started. Oh, I better leave this out there so you can see what I'm doing. So volume equals 2 pi. Here's our lower, here's our upper from 1 to 4. And remember what we decided when we drew the cylinder. The radius is just x. So it's x times the height times the depth. So each cylinder has a depth to it, and that depth right here is just a change in the x's, or the dx, or the delta x. So this is one of the dimensions right there. And now the height is upper subtract lower. All right, so volume equals 2 pi from 1 to 4. The 0 doesn't do anything, so now it's just x times 2, and I'm going to rewrite that as x to the 1/2 and x to the first, because you're going to know your laws of exponents. When you multiply powers of the same base, you add the exponents. So 1 plus 1/2 is 1/2, or 3/2. So volume is equal to 2 pi upper to lower, or lower bound to upper bound, and this becomes 2x to the 3/2 dx. And now we can go ahead and integrate. We're going to leave the 2 pi out, and now let me do this. X to the 3/2 will add 1, so 2 over 2. Well, that becomes 5/2, and then remember what we said, you multiply by the reciprocal, so 2/5. Because think about this way, if you divide by 5/2, you'd multiply down here by 2/5. Yep. So now we have 4 over 5 x to the 5/2, and that is from 1 to 4. We can actually bring this 4/5 out to make it easier. So we can multiply the 2 pi 4/5 to 8 pi 5, and now we just have x to the 5/2 from 4 to 1. And let me see if I can, oops, I can, whoops. I don't want the eraser quite that big. And then I can just keep going. So we can leave the 8 pi 5 out here, and we can say f of 4 subtract f of 1. And notice when the constants are pulled out, this makes it easy. This is 4 to the 5th, and then you take the square root of 4 to the 5th. So this is 4 to the 5/2. Here's an easier way to do this. The 2 is the root. The square root of 4 is 2. 2 to the 5th is 32. And then we're going to put a 1 in there. Well, 1 to any power is going to be 1. So 32 subtract 1 is 31. So now you have 8 pi 5ths, is that right? 5ths. I could not read my handwriting. Times 31. So $248 pi 5ths. So 248 fraction 5 times pi is about 155.8230, and it's units cubed. My thing's in the way. Units cubed. All right, that is the cylindrical shell. Now, they get very complex. This is an easy one. We'll be practicing the more complex ones in class together, and there will be some videos from other YouTube people that have done some complex ones, but this at least gets us started.